Hello, welcome, and an excellent evening. And excuse the background noise, perhaps. I have my Rigol DS1202 oscilloscope set up over here, which you can't see at the moment because I want to show this thing here. But I'm gonna put the screen of that oscilloscope, a screen capture, which is quite low FPS, so it's like only 1 or 2 frames per second, but it's better than nothing, up here, I think, so that you can follow along. That being said, this video is about the FG-100 DDS Function Generator, which is a relatively cheap and affordable function generator. Usually shipped from China. It has no markings whatsoever, and it can do a couple of interesting things. It comes with a 5-volt DC input. It can accept a range from, I think, 3.7 to 10 volts or something. There was a little leaflet here. DC 3.5 to 10 volts, yes. 3.7 volts for lithium battery powered. And it says that it can do sine wave generation from 1 Hz to 500 kilohertz and other waveforms from 1 Hz to 50 kilohertz. We will check that out in a resolution of 1 Hz. The output amplitude decreases with increasing frequency. We will have a look at that. And yeah, I think we can just take a look at this as we see it here, all the buttons. It is not to be compared with really a high-end professional function generator because the specs are pretty low. And the question is, what do you need this for? Good question. You can use it to produce an arbitrary clock, for example, for an old 8-bit CPU. The sine wave goes up to 500 kilohertz. And of course, you could just use a quartz for that or an oscillator. However, here you can tune the clock rate and slow down the CPU to do some experiments and stuff like that. Also, you can feed it into certain kinds of filters or whatever that you're designing to see how do they behave, depending on the waveform and other stuff. Or you can just use it to produce pretty pictures on oscilloscopes or similar things, because there's a couple of interesting things here. The thing comes only with a USB to barrel plug. It didn't come with this BNC cable. This is mine, and I'm already gonna hook this up to the scope now, if I manage to do that. Yeah, that should be fine. And I'm gonna plug in the cable. There are a bunch of buttons here. Power is of course the most important. There's a DC offset button, a filter button. Those are the red buttons. Then you have mode, cursor, plus, minus, and run stop. Let's just press the power button and it greets you with the version number of the software on this thing. I think there's a little Atmel microcontroller inside. The waveform is by default is sine, and the frequency is 100 kilohertz. And you can change this with the mode button. You can switch to square wave, triangle, sawtooth, reverse sawtooth, is basically just inverted. 20% pulse, which is the duty cycle pulse with modulation. It's basically square wave with 20% on. ECG, that's an interesting one. And that's it. Interesting enough, it starts out with 100 kilohertz, but this is something that the things other than sine wave can't even do. Also, you will note that the scope waveform on the top left here has gone down to, let me see, the minimum being minus 2.44 volts. That's quite interesting, and you can actually push this DC offset button, and that was the offset here, and then you can set an arbitrary direct current offset. which I can do right now so that you can center your waveform around. But we're gonna turn the DC offset off for now. So as long as this thing is not running, it pulls the waveform pretty low actually. The mode button is for that. The plus and minus will let you increase or decrease the digit that you're currently on. Let's start off with something more simple. Let's put in 10 kilohertz. You press cursor to move the cursor to the right one field. It's very clunky, the interface, I have to say. And then we have 10 kilohertz. Now you can press the run stop. And as you can see, the oscilloscope up here should be showing a nice sine wave. During this, you can't set anything, which is a little bit annoying. You have to stop everything to do that. The filter button is currently pressed, but I don't see any difference. So I'm not sure what kind of filter is applied here. Nothing that I can see. And you have an amplitude pot, which is relatively finicky and coarse, but you can tweak it relatively easily to get the amplitude that you desire. For example, you can't see the stats, they are not shown here on the display, but basically I'm now dialing into that I get 5 volts peak to peak, which is quite hard because it jumps around quite a lot. So getting a certain amplitude is definitely a bit difficult. It said that the amplitude will go down, so with a higher frequency, so let's try indeed 100 kilohertz and hit run stop. And yeah, the amplitude went down to roughly 4.9 volts peak to peak. The RMS is also going down, I think. RMS currently 1.7 volts. Still a relatively nice waveform, I would say, on this end. And I think we can try to make this perhaps a little bit better. Let's hit the auto button again, because the remote doesn't like the knobs on the device very well. Takes a couple of seconds to read all the instrument settings. There we go. And there we have still, look, this waveform looks still very nice, 100 kilohertz. The counter says 100.00. So that's pretty spot on, I must say. Let's go to the, no, not yet the sine wave. Still, let's go to the maximum that they say on the datasheet, 500 kilohertz. Let's see what this looks like. Yeah, here you can see the amplitude goes down a lot. We have a RMS of 800 millivolts only. So the output energy basically went down quite a lot. Voltage peak to peak is only 2.4 volts at this moment. You can crank the amplitude up, of course, but there might be some distortions. You can already see that the sine wave on the right edge, on the falling edge, basically, if you look up here somewhere, is already kind of degrading. But still, it's quite a powerful output signal. Well, we can even increase this stuff further. Let's go all the way to 900 kilohertz. Then the amplitude goes down even further, but the thing still says here the counter 900 kilohertz. There's now, it's not that accurate anymore, 900.02, so that went down. RMS is 350 millivolts only. I can crank it up, but here you will see already quite a bit of jitter. And I have a 200 megahertz scope, so this should still be ample of bandwidth to actually measure this. There's definitely now getting into the limits of what this function generator can do. But still, I guess you could probably power a C64 from this signal, I guess. But I'm not sure if it's a good idea. Yeah, let's go down again to something better. Let's say 10 kilohertz. And now let's look at the square wave. Let's do run stop and let's dial in the amplitude. And here we are zoomed in at 2 microseconds, and you can also already see that the slew rate is relatively slow. This is only 10 kilohertz, and I would assume that this might be looking nicer. So let's do the auto triggering again. There we go. This, of course, on this zoom level looks much nicer. This is now 20 microseconds per division. And yeah, this is looking quite good. We had 5.5 volts. Let's dial in at 5 volts peak to peak, roughly. And this is a nice square wave. Yeah, looking quite decent, I would say. Let's try the other waveforms. So run stop, triangle, and there you go. That's a pretty clean triangle, I would say. This is something also you could use for generating test tones, let's say. The filter doesn't make any difference from what I can tell. There's a little bit of jumping in the signal on the real-time scope, but you don't even see that. And now with the DC offset, you can use that to shift the waveform up and down, obviously. But that is not necessarily something that you need, especially if you're doing audio signals. You would like to use that if you want to try to produce a custom clock for a CPU or something. That could be quite interesting. Then you would try to make this whole thing like on the low level, basically be on ground level. You could do it via that, for example. Yeah, let's look at the next. Sawtooth, also pretty clean at 10 kilohertz. Looks pretty decent. Next, we have the reverse sawtooth, which is basically just inverted. All good. The 20% pulse, also pretty decent. It's basically just a shortened square wave. Next is ECG. And this is a fun one. I'm not sure why they put that in here. Probably just for yeah, I don't know. If you need that for a movie or something, I don't know, fake ECG. At 10 kilohertz, I would say that patient is probably dead, but yeah. Okay, those are basically all the things that are in here. Let's have another look at the square wave. This is already having a slight slope to the rising and falling edge. Let's try to increase the frequency to 20,000. Still looking relatively good. I'm gonna try and increase the horizontal scale, if that's possible. Yeah, there you go. Yeah, the slope is definitely visible. Let's crank it up further. Let's crank it to the double. Let's say 40,000. Yeah, already getting even more rounded off. There's definitely a slant to the edges. So it's rather slow. And you can see a little bit of a jitter. So there is already kind of like a jitter in the period length of the square wave. Definitely visible. So I guess a high quality function generator would have much better signals at this kind of frequency, because this is still in the audible range. Let's go to the maximum that they are saying that this thing can do. Let's go to 50K. And yeah, we can even zoom in a little bit more. And you can already see very, very diagonal slopes, so to speak. Yeah, that could definitely be better. And still a lot of jittering. You can see that the duty cycle of each pulse is basically varying quite a bit, quite visibly. So that's not a super stable signal anymore. But I guess that's what you have to expect from cheap things as this. I think this one was like 20 euros or something. But what I like is that there's like a lot of different waveforms. That's pretty neat. With the triangle, you already see, and the filter doesn't make any big difference here, rounded off edges. So at 50 kilohertz, this is already hitting the limit, I guess. And if we go to like stuff like, let's say 150 kilohertz, why not? It's getting really rounded off. And I think the cable here should be very well suited. This is a BNC cable, so it should have enough bandwidth, I guess, to reproduce this. Yeah. Let's choose the square wave, perhaps, because that will show the worst distortions. Yeah, this is beginning to not look very square at all, I would say. The amplitude can still be considered pretty okay, I guess, but there's a lot of jitter now, and the things are getting really rounded off. Let's hit the maximum that we can go on paper, at least. Let's go 500 kilohertz and see what this looks like. And this doesn't resemble a square wave anymore. The sine wave was looking much more reasonable at 500 kilohertz, but the square wave is totally broken at this point. Let's look at the triangle wave. And there we don't even trigger anymore because my trigger is all the way down. So now it's better. Yeah, I wouldn't call this a triangle. Let's take a look at the sawtooth, because that should have definite angle to it. Yeah, that's also not working anymore. So I guess if we go here and go down to 50K again, the sawtooth should still be kind of like sawtooth-like. Yeah, it does. Looks actually still pretty decent, but you can see relatively not so steep slope on the falling edge of the sawtooth. Yeah, pretty nice. But as I said, for 20 euros, I think you can't expect that much more. So it's if you need a function generator capable of like producing signals in the audible range for testing audio filters or something, or doing some experiments, that's definitely something that you can use. For injecting clocks into 8-bit 80s computers or something, it might already be at a stretch. It's probably not the best solution. What we can do is we can do one more thing. I can take another probe here, because the scope has a very simple function generator built in for calibration purposes. It's 1 kilohertz square wave, and we can at least compare that to what we have in here. Of course, at 1 kilohertz, this thing here will be pretty okay on its own. So we are going to go to square wave and then go all the way down to 1 kilohertz and run this. And I'm gonna hit the auto button and let it calibrate. And there you go. The blue curve is the scope signal, and the yellow curve is this function generator signal. And they both look relatively decent. You see a little shift. The blue curve is wandering around because you can trigger only on one curve, obviously, and the other curve will be in relation to that. And as they're not phase locked, loop locked, or whatever it's called, they are naturally drifting because they are not exactly 100% 1 kilohertz. As you can see, that's 999.99 hertz, and the other one is probably a bit faster, more closer to 1 kilohertz. At least it says so on my stats here on the screen that you can't see. Yeah, but yeah, for such ranges, a couple of kilohertz, this thing is definitely a good choice. And the ECG feature is kind of a funny addition. Probably looks great if you do this on a analog scope with rolling, basically like in an ECG in a hospital, basically, where the pulses go through and you put this down to 1 hertz or something. That would probably be nice. Let's actually do that. Not on the analog scope, but here. Let's go to ECG and then go down to 1 hertz, I would say. That's a nice calm thing. Then let's do an auto. Let's see if it can actually do that, because syncing on 1 hertz is probably a bit asking too much, and the amplitude is probably too high. Yeah, right. I have to disconnect this and do some manual setup. And there we go. We have a nice rolling display. That actually looks much better in person because it's very smooth. The remote software can't update the screen more than like 2 or 3 times a second. And I think that's a limitation of the scope, sadly. But yeah, there you go. You can make your own fake ECG using this nice little device. Quite interesting. So if you are in a pinch and need a very cheap function generator, I think this will do. If you need something in the megahertz range, then this will not do it. So even for like injecting clocks into old machines, you probably want something bigger, something in the range of 100 or 200 euros. There are some affordable options, I think. I didn't have the guts to buy one yet, and I don't think I really need one, although I find those instruments very cool. But I think from 100, 200 euros on, you will find pretty decent megahertz range function generators as well, even with 2 outputs and stuff like that, which you can use to do more complex things. Anyway, that's it for today. Thank you very much for watching. Have a nice evening. Do like, share, and subscribe. Leave a comment. What else can you do with a function generator? What's their greatest purpose? I don't know. What shall I do with this thing? What kind of nice experiments? But other than that, see you in the next video, and yeah, bye.